Okay, so we're going to talk about quadratic functions, and one of the forms for a quadratic function, there are two forms. The one's called the general form, and the general form of a quadratic function looks like this. F of x equals ax squared plus bx plus c. And we worked with that form before when we were doing the quadratic formula, okay? But that's the general form. The degree of a quadratic function is second degree, or degree 2, okay? So you're going to have an x squared term in it. That's what if you didn't have an x squared term, then it'd be a linear function, right? Okay. So we know the basic quadratic function, doesn't have any frills to it. That would be x squared. And we know what that graph looks like. It's a parabola. And that may not be a perfect parabola there, but it looks something like that shape, okay? Well, now we want to talk more about those parabolas and what they do and their transformations and how we can get more detail out of it and how we can apply that. Okay, so when we're graphing on an x and y coordinate system, and let's say we have a transformation. Let's say that our parabola is shifted 4 units to the right. So we're going to shift 4 right and 3 down. Okay. So I'm going to show you a little trick that I think is really helpful for you. If my old parabola looks like this. Now those are accurate points, okay? You have the point 0, 0, the origin, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Now, if you keep that in mind, and you could make a table of values, okay? Keep that in mind though. Now what we're going to do is we're going to just shift it right and down. So we're going to keep the basic shape the same. And I'm going to do it in black here. So I'm going to take my vertex, whoops, I haven't talked about that yet. I'm going to take the bottom of the parabola and go 1, 2, 3, 4, 1, 2, 3 down. And then I'm just going to make those points as if that bottom of that minimum on the parabola, if it were the new, axis system, the new origin. So I'm thinking about going 1, 1 from that point that I just drew, that minimum point. And then I think about 2, 4, so 2 up, 1, 2, 3, 4. So it's like I'm shifting the axis. It makes it a lot easier to graph these rather than going through like a whole table of values. It's back to the idea of transformations. Okay, so there's our very imperfect parabola that we're going to talk about. Okay. So this minimum point that we were talking about here, that's the vertex. The vertex is where it's changing either from decreasing to increasing, like this case, or from increasing to decreasing. We could have a parabola that's upside down. Now I'm going to go ahead and make another parabola here so we can talk about that. And then that point's not a minimum, it's a maximum, but that's okay. All right, so now I have 2 parabolas there. All right, the vertex then, for my first parabola in black, that point down there, is going to be 4, negative 3, right? That's going to be the vertex, that point, that bottom point in that case. The vertex up here, that's going to be, what did I draw? It looks like negative 6, negative 2 to me. Okay, so I'm going to rewrite those for you so you can see them better. But the first one, it's having a 4, whoop, it was supposed to be a negative 3, wasn't it? Negative 3 for the vertex. And the green one had a vertex at negative 6, negative 2. Okay. So that's the vertex, that bottom, either the bottom point or the top point on your parabola. Okay. the axis of symmetry. The axis of symmetry is the vertical line that goes through, sorry about that. It's the vertical line that goes through the vertex, okay? So on your standard parabola here, the axis of symmetry, they usually make it a dotted line because it's not part of the graph. That is your axis of symmetry. And what you're saying is I could fold on that dotted line and the points on the left would line up with the points on the right, okay? So on the other one, I have my axis of symmetry going through here. And on this one, I have the axis of symmetry going through there, okay? Now, those axes of symmetry have equations. They're vertical lines, okay? So for the black parabola, x equals, this is how you write the axis of symmetry. X equals, and then whatever that number is, it's 4, right? So you can read that off the graph. The green one has an axis of symmetry, x equals, and it's going to be -6. Remember, it has to go through the vertex. That's the thing about the axis of symmetry, okay? But you get this vertical line. So you want to be writing the equation for a vertical line when you do the axis of symmetry. The other thing we talk about is intercepts. So for the orange parabola, the basic parabola, the y-intercept, oops, that did not go, oops. The orange one has a y-intercept at, let me do that differently. Y-intercept is at 0, 0. And so the x-intercept is also 0, 0 for that one. For, let's see, I'm going to scroll this up a little bit. So for the black parabola, what do those intercepts look like? Well, we can't really tell. We could approximate them, and we'll find a better way to do it. But the x-intercepts, it looks like it's about 6.1 or something for x-intercepts. So there's one at, well, I did the further one first, 6.1 comma 0, and the other one looks like about 2.2 maybe. I'm just kind of guessing. All right, those would be the x-intercepts. The y-intercept, well, I can't even read the y-intercept, but there is one. I would have to extend this, and I don't know, maybe it's like 10 or something. We're just kind of guessing there. But that's what the y-intercept would be. Now the green one's going to be even more difficult. Well, in some way. First of all, the green one has no x-intercepts. So if they ask about the x-intercepts, there are none. Don't put 0 because that would be confusing. Where's the y-intercept? Well, again, I can't really see it. I have to extend this. It's going to be, I don't know, maybe we'll say 0, -20. Okay, so we're just kind of guessing on those. But just so you understand what the y-intercepts and x-intercepts are. Okay, they're going to use the phrases zeros or roots. Zeros or roots are the same thing as x-intercepts. So if they say, hey, what are the x-intercepts? Same thing as what are the zeros, same thing, what are the roots, okay? So they use those three terms interchangeably, but they're talking about the same 3 points, okay? All right, that's that long video.